Hello, you're welcome. All right, so now we have a topic that we're going to be discussing here in this video tutorial. So it's called frictional force, right? So now we'll start by defining the term frictional force. Now, in physics, forces are being classified into two, right? Now we'll have the contact force and field force. Okay. Now, frictional force is an example of a contact force because it's a force that is actually in contact. Okay, with the body that is actually experiencing the force. And of course, this is a contact. It's called a contact force because there's a contact between the body experiencing the force and of course, the body that is exerting the force. So, frictional force is an example of a contact force. So, what is a frictional force? A frictional force is a force that opposes the relative motion between two surfaces in contact. Okay, so please take note of that. So any force that opposes motion, relative motion between two surfaces in contact, that is frictional force, right? Now types of frictional force. Now there are types of frictional force, but you're going to look at two basic types of frictional force, right? There are many types, but you're going to look at the two basic, all right? The frictional force are divided into we have static friction and of course we have dynamic friction, all right? Now as the name implies, static friction is a friction, okay, so strong enough to keep the body at rest. So a body is expressing static friction because that the frictional force on that body is strong enough to keep the body at rest. So in static friction, there is no movement. Okay, the body that is experiencing the friction is not moving; it's at rest. Now, while dynamic friction is the frictional force that exists to oppose the motion of a body. Okay, of a surface already in motion. So now you discover that between static friction and dynamic friction, okay, static friction is said to be greater than dynamic friction. Why? Because static friction is stronger, okay, than is strong enough to keep the body at rest. While in dynamic friction, that frictional force has been overcome by movement, right? So please take note of that. So now here we're going to be looking at characteristics of frictional force. All right, so now number one characteristic is still the same thing we know about friction. Okay, is that frictional force opposes the relative motion between two bodies in contact. Okay, yeah, this is basic. This is the definition of frictional force. Then number two is that it is independent on the nature of it is dependent on the nature of surface. Rough surface have more friction than smooth surface. Okay, all right, so when the surface is actually rough, you will experience more frictional force. When it's smooth, okay, you experience a less frictional force. That's what is known as perfectly smooth force. When the smoothness of a surface is perfect, okay, perfectly smooth. Smooth means there is no friction. Perfectly smooth means there is no friction at all, right? So a perfectly smooth surface has zero frictional force. Okay, let's still get more characteristics. Okay, so let me start from number three and look at. Okay, here we go. Okay, bring it on the screen. Okay, here we go. Right, number three. Okay, it is independent on the relative motion between the two surfaces. So whether the motion is the motion of the two surface is faster or slower, okay, the frictional force is independent of it. So please take note of this. Okay, take note of the dependent and independent. Of course, number four, it is independent on the surface area in contact. All right, please take note of this. The surface area of the surface in contact. Okay. Now it is directly proportional to the normal reaction of the surface. Now this number five, the frictional force is directly proportional to the normal reaction of the surface, okay, in contact, is what will give us the formula of frictional force. Alright, now let's say how do we illustrate that? Now let's say we got a surface, alright? Let me draw a surface. Let's say you got a surface. And of course excuse me. They have a body on this surface, okay? Now I told you that the weight of the body is actually going to be acting now while the surface will support the weight of this body by a reaction. So now according to what we have here, frictional force is directly proportional to the normal reaction, okay? So we can say that frictional force is directly proportional to the normal reaction. We use this symbol to represent normal reaction. Okay, it looks like U, so it's how you want to put it, but it looks like U, but we call this, oh sorry, please pardon me, I made a mistake. The normal reaction is a constant, please pardon me. We use R to represent normal reaction, okay? Normal reaction is simply normal to the surface. Okay. Of course, a normal reaction is actually that particular reaction that a body actually uses to withstand the weight, a surface uses to withstand the weight on top of it, all right? So we said that the frictional force is directly proportional to the normal reaction. So it is now when we actually want to remove this proportionality, I introduce an equal to, okay, that will bring a constant, and that constant is now what has this symbol, okay? And of course, this symbol, excuse me, all right, now this symbol, look at, let me write it again. Frictional force is equal to the symbol known as mu, okay? It's a symbol. It's a symbol, it means something, okay? We are pronouncing this symbol as mu, okay? So this is how I pronounce the symbol. Now, what is the meaning of this symbol, that symbol, okay? As a constant. Now, frictional force has what is known as a constant, known as the coefficient, okay? Coefficient of frictional force. So that means every surface that actually offers friction, okay, has a constant known as coefficient of frictional force. That's what that U represents, okay? So if you don't want to call it mu, you can call it U. The name of the symbol doesn't matter, okay? It is the name of the constant that matters, so we call it coefficient of frictional force. So please take note of this. This is the formula of frictional force, all right? The same way we know that we have the formula of force also being according to Newton, okay? The formula of force can also be this change in momentum, right? So remember, all these formula of forces, they are important, right? Then in terms of friction, formula of frictional force, in terms of frictional force, this is the formula, all right? So please take note of that. All right, so we actually proceed now to the next subtopic. Okay, so probably let's see if there is some question we need to answer. Okay, here we go. I'll bring that question, I'll bring it up. All right, so this question goes like this. 100 kg bus is pushed along a road with a force of 500 Newton. If the bus moves with a uniform velocity, the coefficient of frictional force between the bus and the road is, okay? So according to the question, the bus is being pushed with the force of 500 Newton, right? All right, so and we are we are told that bus is the mass of the bus is 1000 kg. So now we are now asked to calculate the coefficient of frictional force. Okay, so how do we calculate this? So we use the formula of frictional force. F is equal to UR, okay? So now, okay, let's see how this works. Okay. So since we have this, okay, we know this already. Now ask yourself, how we already know the force, okay, then how do we get the normal reaction? Please, normal reaction, okay, take note of this. Normal reaction is always equal to the weight of the object on the surface, okay. Let's say you have a surface that a surface in which weight m is actually on it, okay. Remember, the mass will actually exert a weight of mg, okay. So this particular surface will withstand with a reaction, and of course, for this weight to be on this surface, the reaction must be equal to the weight. So please take note of this. Normal reaction is always equal to weight of the body on top of the surface. All right, so please take note of that. We are not going to put it in that formula, so we now have that F is equal to coefficient U, okay, multiplied by the normal reaction, which is mg, okay. So we put the value there. So F is equal to 500 Newton. Mass is 1000. Then times G is 10, right? So that makes it 10,000, right? So we can now simply say that, okay, the coefficient now is going to be equal to 500. All right, 500 then divided by 100, right? Excuse me, 00, right? So that should give approximately 0.05, if I'm not mistaken. So you confirm that. And the coefficient of as you can see, coefficient of frictional force does not have any unit. Why? Because, all right, let me. Coefficient of frictional force doesn't have any unit. The reason being that the coefficient of frictional force from this formula is always the frictional force, right, divided by normal reaction. Both frictional force is in Newton, all right, and normal reaction is also in Newton. Reaction, remember Newton's law, force, for every force there's equal and opposite reaction, okay. So they are all forces, okay, and they Newton. So Newton cancel Newton. So that means the coefficient of frictional force doesn't have any unit. So please take note of that. All right, I hope that actually clear up some certain principle to you, right? So now we're going to continue. So having known that every surface has its own coefficient of frictional force, okay, so we're going to look at how to determine the coefficient. It's a coefficient of frictional force is a constant, so please take note of that. Okay, so I'm gonna bring up the subtopic. All right, here we go. So now we say that there's a constant, okay, that is dependent on the surface, okay. So any surface we have has its coefficient of frictional force. Now we are going to start by determination of coefficient, okay, of static frictional force. Please take note of that. So we are starting with the static frictional force, which of course is a frictional force that keeps a body at rest, okay. Now remember, in static friction, the body is still at rest. That means that the net force acting on it is equal to 0, okay. That's for static frictional force. Now to determine the coefficient of static frictional friction, okay, we will consider two surfaces. So we're going to look at static friction into surface, okay, into surface. How to determine it, we'll see how we get it into surface. The first surface we're going to consider is a surface that is horizontal, and you can see in this diagram this surface is horizontal, okay. Now the surface is horizontal. As you can see, you have mass m1, all right, being placed on the surface. Then it is connected with a rope to another mass m2, all right. Now the whole idea is this: if mass m2 is heavy enough, okay, it will be able to pull on mass m1 to cause it to move. So mass m2 is what actually pushes on mass m1, pulls on mass m1 to move, all right. So please take note of that. But fortunately, we are considering static friction, so we are made to understand that mass m1 is not moving. Why? Because the frictional force on it by the surface is too big, all right, okay, to keep it at equilibrium. So in that case, now we can simply say that the frictional force on this body, are you okay, is equal to the force that is pulling it. And of course, the force that is pulling it is the force on the tension on this string, okay? Remember, as you can see, this string is being pulled by M2, so there's a tension that's pulling this. So we can simply say that, all right, the force, the frictional force, are you okay, on the M1 is equal to the tension. Remember, two of them, both frictional force and tension, they are opposite. Tension is moving the body, frictional force is acting against it, opposite, okay? So frictional force is equal to the tension. And from the formula of frictional force, we know that frictional force is mu normal reaction, right? And the tension is equal to the weight of the mass that is pulling. And of course, the mass that is pulling this body is M2, okay? So tension here is equal to M2 multiplied by G, okay? That's the tension. So in that case, now if we want to get this, we're looking for this coefficient of static friction. So it's going to be M2, right? Multiplied by G, then divided by normal reaction. Now remember when I told you that normal reaction, okay? Normal reaction is equal to weight. So, but we already know that the normal reaction, right, is equal to the weight of the body on the surface. The body on the surface is M1, okay? So the weight is going to be M1G. So that case now we can simply say that, okay, coefficient of frictional force is equal to M2G, right, divided by M1G. So G cancels G. So we now have M2, right, all over M1. Alright, as simple as that, M2 all over M1. That is it. Okay, so please take note of that as we proceed. So now that is for so this is for a horizontal plane, all right? So anytime you're being asked how do you determine the coefficient of frictional force in a horizontal plane, just do M2. M2 is the mass that is pulling the body on the surface, while M1 is the body on the surface, all right? So please take note of that. That's what we just described here. Now I'm gonna clean up. Now let's look at another surface. We are considering two surfaces, the horizontal surface, okay, horizontal plane. Then we'll look at a plane that is inclined, an inclined plane, okay? This is how inclined plane looks like, as you can see here. Alright, the body is being placed on an inclined plane. Alright, it slides down. Maybe perhaps I will draw this inclined plane myself, alright? Something of this nature, okay? So you now have a body is placed here. Alright, let me call it M, and of course every inclined plane is always inclined to an angle theta. If we should place a body here, discover that without even pushing it, okay, if this angle is inclined enough, if you bend this plane enough, okay, this body will start sliding on its accord downward. All right, now I don't want to actually prove some certain proof formula here. All right, I don't want to spend time trying to prove formula here, but I'm going to illustrate some basic thing, okay, that leads to the formula. Remember, what you're looking for is the coefficient of static friction, right? Okay, so now look at what I'm gonna look at. Now, when a body is placed on an inclined plane, okay, there's something you should know. Okay, one of the things that you should know is that the force that's acting along the plane is mg sine theta. All right, force that is acting along the plane is mg sine theta. Okay, so along the plane is mg sine theta. Weight of this body sine theta. Remember, the weight of this body is mg, all right? Mg sine theta. So the force that, without applying any other force on this particular body, that force due to that will just cause this body to slide down, okay? Now remember, that force will be opposed. If this body should naturally slide down, that means the motion is downward, okay? There's going to be an opposition to each, and of course, frictional force is the opposer of motion, and that is going to be opposite, okay? So which simply means that a static frictional force. So let's say this body is not actually moving, okay? So it simply means the frictional force that is on it should be equal to the force that is actually pushing it down, which is mg sine theta. All right? So now, we already know that frictional force is giving us mu normal reaction, right? And of course, equal to mg sine theta. Now, please take note that an inclined plane, this normal reaction, okay? Normal reaction is weight of the body, but the weight is inclined at an angle, okay? So the weight have to be resolved. And I don't want to go through the process of resolving the weight. So the weight is Tmg, okay? The weight on the body on the surface is Tmg, but you have to resolve it, okay? By attaching cos theta to it. So I have to resolve it in the horizontal dimension, okay? So let me now go through that process. So we'll have that mu r, which is mg cos theta for an inclined plane. Please take note. For a horizontal plane, the r is just mg, but for an inclined plane, the weights, okay, the normal reaction is mg cos theta. All right, so u mg cos theta is equal to mg sin theta. All right, remember the whole of this idea is for us to get our u or mu. All right, so that means our mu now is going to be equal to mg sin theta, right? If I make it the subject, it's all over mg cos theta. Mg cancels mg, so I'm left with mu for an inclined plane is equal to sin theta all over cos theta. And of course, sin theta all over cos theta in trigonometry is equivalent to tan theta. So please take note of this. For an inclined plane, the coefficient of frictional force or the coefficient of static frictional force is simply tan theta. That's it. So once you do the tan, theta is the angle of inclination. Theta is the angle at which the plane is inclined, okay? So once you do tan theta, you have evaluated the coefficient of static frictional force. All right, at this junction, we have actually proven the coefficient, the formula for the coefficient of frictional force for both a horizontal plane and inclined plane. So let's see if we see question. Okay, we're going to apply some question that will help us understand better. All right, here we go. All right, so let's go there. So I paste this. So I'm having this now. It goes like this. If an object just begin to slide on a surface inclined at an angle of 30 degrees to the rotor, the coefficient of friction, simple. So there's no need of me trying to go through any long process, okay? So the angle of inclination is 30 degrees. So the coefficient of friction is simply tan 30. Alright? So once you use your calculator and evaluate tan 30, that's it. You've gotten this. It's as simple as that. Okay. Now we can use if you want to use special angle, that you can find tan 30 special angle is just 1 over root 3. Okay. Remember special angle, so you can go back to that again. Okay. So as simple as that. Any other questions? Alright, so now the next we're going to look at is dynamic friction. Let's see how dynamic friction works. Remember, in static friction, that body is being placed at rest. It's not moving, okay? So, but dynamic friction, which we're going to be looking at now, dynamic friction. Now, in the dynamic friction, the body is in motion, okay, which means that the net force is enough to cause acceleration. So that means that body force, the force that is actually pulling the body to move, okay, has overcome the frictional force. So that is what is known as net force. Net force is actually used. The net force or resultant force is used when there are two forces that is opposing each other, or two forces act on the body, or more than two forces. Okay, please take note of that. Okay, so now when you counterbalance the forces, you still have some force that will cause motion. Okay, when the net force is more than 0, that means the force that is left after subtracting the opposing forces, okay, is actually more than 0. So it can actually cause motion. So now look at the principle we use for dynamic friction. We use that, okay, for dynamic friction, the net force on that particular body on the surface, okay, is equal to its mass times acceleration. All right, so you can just do this. F net is equal to mass times acceleration. Okay, mass times acceleration. All right, so which simply means that you need to find the F net, okay, of that particular distance. So we're going to consider it both in horizontal and in an inclined plane. Okay, so I think I'm going to consider it in horizontal and inclined plane. Let's start with a horizontal. Okay. All right, I will show you how it works in a horizontal. Okay, let's say this is a horizontal surface, as we already know. Okay, an object is being placed here, then a pulley is being placed at this point. Then of course there's a connection. There's a connection of rope that actually connects the force. Alright, this M2, right, and this M1. Alright, so now this as a frictional force represented by this. Okay, so let's see how that works. Now for a dynamic friction, we saw that net force, right? Net force, let me call it F net, is what actually causes mass times acceleration ma. Okay, so F net will actually, if the F net is greater than 0, net force, it will cause this body to move. And remember, when M1 is moving, M2 is also moving. So how do we get the F net? Remember, what is pulling this is tension. Are you okay? So we can simply say that, okay, the F net is gotten. Remember, force is acting opposite tension. For you to get the resultant or net force of two opposing forces, you subtract them, okay? So the net force for a horizontal surface is going to be T, the tension, all right, minus the frictional force. So by the time you subtract frictional force from the tension that is pulling this object, which will be, you have a value that is greater than 0, okay? And of course, it is what will cause the acceleration. And remember, two of them will accelerate, okay? M1 and M2 will accelerate. So for M, both M1 and M2, are you okay? So you have to add the mass. The mass is not just one mass, will definitely accelerate. All right. So how do we do this? Of course, you know that tension is equal to the weight of this pulling mass. The weight of this pulling mass, that is the tension, okay? So the tension is M2G. While of course, you know the frictional force is mu normal reaction, okay? Mu, the normal reaction is the weight of the object on the surface, M1G. All right. Okay, it's equal to M1 plus M2, then multiply by A. As simple as that, okay? Let's see if there's a question that we can apply based on dynamic friction. All right, so that's an example. Here we are. So I'm going to bring it to the screen. Okay. So I clean up. I just bring this right to the screen. Now we have this surface, right? Having two forces, the force 3 kg and the force 6 kg. Alright, the 6 kg is pulling on 3 kg. So the question goes like this. In the figure above, the coefficient of static friction is 0.5, okay? If the tension in the string is T, the acceleration of the system is, so we are looking for the acceleration of the system. Don't forget the formula, okay? For this system to move, right, we have that the formula, the tension, of course, M2G, the tension of this pulling minus the frictional force, okay, which is mu normal reaction, of course, normal reaction M1G, okay? This equals to the net force. The net force, are you okay, is equal to the mass and acceleration of the system. So we got to M1 plus M2, which will be accelerating at the same time. That's acceleration. So we're looking for this acceleration. So let's start putting the value. M2 is 6, right? That's 6 times 10. Then minus mu, the normal, the coefficient. The coefficient from the question is given as 0.5, right? Then times M1. M1 is 3. Times G, which is 10, right? Okay, it's equal to M1, M2, 3 plus 6. Then multiply by A. Please pardon me. So this is going to be 60. Let's do this. 3 times 10 is 30. 30 times 0.5 is 15. So please take note of that. Alright, this here, 3 plus 6, that should give me 9. That's 9A here, right? When you subtract this, I think this gives me 45. Alright, if I'm not mistaken, 9A. So A will now be 45 divided by 9, which of course is 5 meters per second. 5 meters per second square. Alright, as simple as that. Let's see if we have more questions to solve. Okay, there are questions. Let's see. I have another question here, right? I place it on the screen. This goes like this. If an angle of inclination of an inclined plane is shown above is 30 degrees, and M1, M2, okay, so there's an inclined plane shown above, so I should bring that inclined plane. Okay. The inclined plane they are talking about is the one I used for the example, okay? So I think it should be this. Alright, so alright, so here we go. Okay, this is what you're looking at. So the inclined plane, so example, if the angle of inclination of the inclined plane is 30 degrees, that means the angle here, this theta is 30 degrees, okay? M1 and M2 is 30, so M1 is 30 kg, right? M2 here, according to the question, is 50 kg, right? 50 kg. Alright, so the question now becomes, what is the acceleration of the system? Okay, so this for an inclined plane, you know how we do for an inclined plane, okay? It's the same formula. For an inclined plane, okay, you know that the force, the pulling force for an inclined plane, for this inclined plane is M2, is still M2G from here, okay, M2G, right? Then minus the frictional force. Remember, frictional force, mu normal reaction. The normal reaction of an inclined plane, okay, alright, is normal reaction of an inclined plane. Mu normal reaction. Remember, the normal reaction of an inclined plane already I've given you what it is. That is M1G, right? M1G. Then of course you have to cos theta must be included in it, right? Alright, M1G cos theta, right? Okay, so it's equal to, alright, the system, the moment of the system, M1 plus M2, for the system will accelerate, right? Multiplied by A. So let's do this. This is gonna be M2G, right? For an inclined plane. Then already for an inclined plane, the coefficient of static friction is just simply tan theta. Okay, it's tan theta. tan theta, right? M1G, right? Cos theta equal to M1 plus M2, right? Times A. Now we are still going to do this too. I want to prove this formula, right? M2G, tan theta, you know, is gotten from sin theta, right? All over cos theta, you know that already. Then M1G cos theta, right, is equal to M1 plus M2 all multiplied by A. So cos theta cancels cos theta. So that what you now have is that we have M2G, right, minus M1G sin theta. So that's for an inclined plane. That's how we actually derive the net force, okay, for the dynamic friction. The net force for dynamic friction, okay, M1G, right, sin theta, right, okay, is equal to M1 plus M2. Alright, so we can now put our values. Remember, according to the question, we are told that M2 is 50 and M1 is 30. So that's going to be 50 times 10, right? This is 30 times 10 times sin theta. The sine of the angle is 30 sin 30. So equal to M1 30 plus 50 multiplied by A. So this is going to be 500 minus 30 times 10, that's 300. 300 times 0.5. So this is going to be equal to 80. 80A. So that's going to be 500. 300 times 0.5. That gives me 150, right? Okay, equal to 80A. So 500 minus 150. That gives me 350, right? Equal to 80A. So invariably now, A is going to be equal to 350 all over 80. So you can use calculator and finish that. So that is how we also evaluate dynamic friction for an inclined plane. Okay, so it's as simple as that, right? Okay, so I think the last part of this frictional force is getting for you to be able. There's still some other question, but let's talk about how we can reduce, all right, the advantage and disadvantage of frictional force, and of course how you can reduce frictional force. All right, so that's what we're gonna talk about now. Okay, so let's look at that. So we'll start with disadvantage. All right, I'm gonna place the note on the board, right? Okay, so I will bring it to the screen. All right, so here is disadvantages. All right, so now this is the first disadvantage. One of the disadvantage of frictional force is that it causes wear and tear. Okay, so as that body keep on moving on the surface, okay, it will causes wear and tear. No matter what happens when a tire runs on the road for a long time, okay, it will wear out. It goes the same with shoes, okay. So that's because of the frictional force causes wear and tear. Okay. Number two, it opposes motion, thereby reducing speed. Right? As simple as that. It generates energy which is lost as heat, thereby reducing efficiency. Now, whenever you rub two bodies rub together, okay, even in generator, even in every motor, you discover that after an engine operates, if you touch it, it's hot. Why? Because that movement, okay, that is caused by rubbing a surface against another surface generates heat. Try rubbing your hand for a very long time. Then feel your palm. Try rubbing your palm for a very long time. The two of your palm, okay, and feel it. It's called that is hot. Now imagine when that happens with an engine, okay, they rub against each other for a very long time. Definitely they will generate heat. Are you okay? And that heat is not part of it. Does not contribute to the engine. Rather, it's a heat that is lost. Okay, and of course it reduces the efficiency of the engine. And of course, number four disadvantage is that it can lead to knocking of engine. Okay, of moving parts due to thermal expansion. Remember, when this heat, okay, due to friction, is so much, it will lead to a point where those metals, okay, that is actually rubbing against each other will expand, and so that's what happens. Once they expand, they cannot move freely again. Such is at that point you can say that such engine has actually knocked. That's knocking. All right, the engine has knocked. All right, so advantage of frictional force. Now everything that has a disadvantage also has some advantage, right? Now it helps in firm grip of both and not. So anytime you are looking at firm grip, frictional force contribute to it. Without frictional force, there won't be a firm grip. Okay, both are not, even nail. All right, that is actually fastened against a wood. That grip of nail to a wood, okay, is due to frictional force. Nail can fasten into a wood firmly due to friction, right? It helps for easy movement, okay, of the leg without slipping. You can walk freely. If you walk in a surface that is smooth and of course that is slippery, okay, due to less lack of frictional force, that this tendency that you fall. Please take note of that. So how do we reduce frictional force? All right. Now, if you had to reduce, one of the way to reduce frictional force is always applying lubrication. Lubrication, okay, in form of grease oil. That's why every engine that you're working always have lubricants, okay, oil, and of course you need to put that, or else friction can cause knocking. All right. Apart from that, you can also streamline the body, streamline the moving parts, streamline them, all right, to reduce friction. Okay, so you can actually look up more ways to reduce friction on your own. All right, so far so good. That is it of friction, and we are going to look at more questions in our next video. All right, see you in the next video. Thank you very much.